authorization folder. Let's create a new class inside of this folder that I'm going to call custom claims transformation. This will be a class that's going to implement my iClaims transformation interface. And this interface only has one method, giving you access to the claims principal, which allows you to add more claims to this claims principal object. Here's what I'm going to do inside of the transform async method. First of all, I'm going to make it asynchronous, and then I'm going to check if my claims principal already contains the claims that I will be looking for. So I will say principal has claim, and then I'm going to look for a claim where the claim type is equal to the built-in claim types, and I'm going to look for the claim type called role. This is the claim type that is expected by our authorized attribute in the user's controller. I'm also going to do one more thing, which is going to make our life easier later when we are implementing resource-based authorization, and that is to look for the subclaim. So I'm going to say claim type equals, and then I'm going to say JWT registered claim names. I'm going to use one in the JSON Web Tokens namespace, and I'm going to use sub as the expected claim name. So if our claims principal already contains these claims, then I can just return the principal object and leave this method. The reason I'm looking for the subclaim is because ASP.NET Core is going to transform the incoming subclaim on my JSON Web Token into the name identifier claim. So the subclaim itself will not exist anymore. So what do we want to do in the remainder of this method? We want to fetch the roles and the user identifier for the currently authenticated user and add them as the claims on our claims principal object. To implement this, I'm going to add another class, which I will call the authorization service. This will be an internal and sealed class that I'm only going to use inside of my infrastructure project. And what I want to do here is to inject my application database context instance, which means that this will be a scope service. And I want to implement one method on this service that's going to return the roles for the current user. I'm going to need an object that I'm going to return as the result of this method. So let's create a new class that I will call the user roles response. It's going to have two properties. One will be the identifier for my user, and the second property will be a list of roles that are assigned to this user. So let's create a public list role property. Let's call it roles, and we're going to give it a get and an init setter and a default value of an empty list. I'm also going to move this into its own file and go back to the authorization service. So now I can use my user role response as the result of this method, and let's call this method get roles for user async. The argument for this method will be the identity ID, which will come from the name identifier claim, and what I can do with this is write a simple LINQ query. So I'm going to say database context and then access the user set, and I can start writing my LINQ query. First of all, I want to filter my user table to check that the identity ID is equal to the one that we specified in this method. And then when I found my user, I can project the user into a user role response. So I'll say new user roles response, and let's assign the properties. So the ID will come from the user ID property, and then I'll assign the roles by saying user roles and then calling toList. Now I just need to materialize this from the database. For example, I can use first async and I can return my user roles response. I'm going to use this service from my custom claims transformation, and I'm going to start by injecting an iService provider, which I'm going to use to create a service scope. So now that I have my service provider, I can create a new scope by saying service provider create scope. Then I can use the scope to resolve my authorization service by saying scope service provider get required service, and I'm going to specify the authorization service as the one that I'm looking for. Now I need to call my authorization service, get back the roles for the current user, and assign them as custom claims. So let's start by getting the identity ID from the claims principal. I already have an extension method, which is called getIdentityID. It's defined inside of my claims principal extensions class, and it's just going to look for the name identifier claim. If I go back to my claims transformation, I can now obtain my roles by saying authorization service and calling the getRolesForUser method and passing it the identity ID. Now I need to create a new claims identity instance where I'm actually going to be assigning my new claims, and then I can add this claims identity instance to the existing claims principal. So first of all, I'm going to say claims identity, add claim, and we're going to give it a new claims instance. The type will be JWT register claim names, and we're going to add the subclaim by specifying user roles ID. Of course, I need to call toString. And then for the roles, I'm going to say for each, and we're going to iterate over the user roles value, which are just going to be the individual role instances, and we can call add claim and add a new claim instance. The type will be claim types role, and the value will be the role name. Then I'm going to access my original claims principal, and I can call add identity and give it my new claims identity value. And with this, we implemented the claims transformation, and we're going to assign the subclaim and the respective roles when authenticating with our API. We need to register this with dependency injection. So let's go ahead and create a new method here. It's going to be a private static method. Let's call it add authorization. And for now, I'm just going to inject an iService collection interface. We're going to do two things inside. First of all, I'm going to add a scope service, and I'm going to specify my authorization service as the scope service that I want to register. Then I need to register my custom claims transformation. So I'll say add transient. We want to register it as an iClaims transformation implementation, and let's specify our custom claims transformation as the implementing class. We also need to call this method from our original add infrastructure call. So let's say add authorization, pass it the services, and we are ready to test the implementation of roles authorization. Let's start by logging in the user and obtaining our access token. Then I'm going to try to call the /me endpoint, which is going to return information for the currently authenticated user, and we're going to use the JSON token that we just obtained. So let's send this GET request to our endpoint. We hit the breakpoint inside of my custom claims transformation class, and let's walk through the transforms async method. First, we're going to determine that the role and the subclaim are not present on the claims principal. Then we're going to create a new scope instance and resolve the authorization service. We're going to obtain the identity ID that is already present from our JSON web token, and you have to recall that this matches the identity ID column in the database. Then we're going to get the user roles from the database, and this will give us the actual user's ID and the one role that we already assigned, which is the registered role. Then we're going to create a new claims identity instance and assign it the sub and the role claims. Finally, we're going to add the new claims to the claims principal, and we're going to continue our API request. And you can see that we get a response back from our API containing the user information, and our roles authorization is working as expected. Now that we have roles authorization in place, we can discuss some more advanced authorization approaches. The one I'm going to show you is permission-based authorization, which is a way to apply policy-based authorization in ASP.NET Core. If we take another look at the authorized attribute, you will see that the main argument here is the policy. You can also specify the policy using the policy property, and this allows you to specify custom authorization policies on your endpoints or controllers. For example, we could specify a user's read policy, and the user who is authenticating with our API would have to satisfy this authorization policy. You also need to add the required logic to verify this authorization policy, and I'm going to show you a very elegant way to do this. But first of all, why would we want to do this to begin with? Roles-based authorization, like I showed you earlier, is a very coarse-grained approach to authorization where users either belong to a role or they do not. Permission-based authorization is much more fine-grained than this because you can create custom permissions for each use case or endpoint in your API. You can also decide which role or which group of users will have access to particular permissions, so in that regard, it's a much more flexible solution. It's also very helpful if we can manage permissions from the database, so let's go into our domain layer and create the permission entity. We're going to use a similar approach to what we did with the role, only this time we're going to create a permission. So let's add a new class and let's call it the permission. I'm going to use a similar approach to what I did with a role. We're going to have an ID and a name property and the constructor to instantiate a permission. we're going to have an ID and a name as the argument, and we're going to assign it to the properties. I'm also going to make this a public class. Now I want to define a public static read-only field returning a permission, and let's call this permission the user's read. We're going to give it a new permission instance with the ID of 1, and the permission name will be users read. An alternative implementation to this would be using enums to define your roles and permissions, and it might be better in terms of maintenance from a code perspective. However, I much more prefer to manage my roles and permissions from the database, because now I can update the roles and permissions without making changes to my code and redeploying the application. When it comes to the permission entity, I want to associate it with a particular role, so the roles themselves will have a collection of permissions, which is why I'm adding a permissions navigation property. I'm also going to create my many-to-many role permission entity, so let's create a new class, and it's only going to have two properties inside, which will be my role and permission ID. I'm doing this so that I can seed these values from my EF core migration, but you don't have to do this. You could manage this directly from the database. So let's go into the infrastructure layer and create our NAD configurations. I'm going to start with the permission configuration, where I'm also going to seed my initial permission. So let's add a new class inside of the configurations folder, and I will call it permission configuration. We're going to implement the init type configuration interface and specify the permission as the generic argument. Let's implement this interface, and I'm going to define my table to be called permissions. I'm only going to add my primary key by saying has key, and then let's specify the permission ID as the primary key, and I'm also going to seed initial data by passing in my user's read permission. You can have as many or as few permissions as you want. This will all depend on the level of granularity and control that you need from permission-based authorization. I also want to add a configuration entity for my many-to-many class, which will be the role permission entity. So let's also implement the configuration for this class. So this will be init type configuration of the role permission type. And let's implement this interface. I'm going to assign this to the table called role permissions. So let's specify that value. For the key of this table, I'm going to use a composite key. So let's use the role permission to instantiate a new object that's going to contain my composite key, and the components will be the role ID and the permission ID as the unique values. And then I can seed my initial data by saying has data, and I can pass in a new role permission instance and assign the primary keys. So for the role ID, I'm going to use the role registered ID, and then for the permission ID, I can use permission users read and specify the ID value. Now I'm ready to create my database migration and seed my permission values. Here's the migration that EF Core generated for us. You can see we are creating the permissions table and the role permission table, which is the many-to-many table connecting roles and permissions. And we are also taking care of seeding our permissions and the respective association between the registered role. So now that we solved the data management aspect of permission-based authorization, let's also solve the authorization aspect. I'm going to start by changing how we assign the permission on the controller level. You could use the authorize attribute, but I prefer having a more concrete way to specify this. So I will usually create a custom attribute that I call the has permission attribute, and it's just going to be a simple class implementing the authorize attribute that we were already using in the controller to begin with. All I'm going to do here is define a constructor accepting a string representing my permission value, and then I'm going to assign this to the base constructor to specify my policy value. If you hover over the constructor, you will see that the policy is the argument that we are passing in. And what this allows me to do is to replace my authorize attribute here with the has permission attribute. One more thing I like to do is to create a static class similar to like we did for the roles, so that I can define my permission values. The actual value in this case is the user's read permission, and this is its value, and let's call this the permissions. I'm going to move this into its own file, and now I can use this from my user's controller to specify my permissions by accessing my static class and then the permission value. If you want to, you can have both role-based and permission-based authorization, but this doesn't really make sense because the permissions are connected to the roles, so you can just leave out the roles and only rely on permission-based authorization. The next thing we need to do is to implement a custom authorization